Intel has developed the processes to remove and replace high-density electronic components packaged in a ball grid array, or BGA format, with a high success rate. For package-on-package, or POP devices, these guidelines include developing the proper thermal reflow profile, the correct PCB pad site dress and cleaning, and new component preparation methods. Differing from board assembly, board rework typically uses a hot air rework station. Guided by a thermal reflow profile, the rework station is able to provide localized heat from the top heater to the target component site, while maintaining uniform heating to the underside of the board to prevent thermal warpage to the PCB. The thermal reflow profile specifies the relationship of temperature over time produced by the rework machine. To create the correct thermal reflow profile for board package rework, a profile board needs to be made. The profile board has thermocouple sensors mounted at key locations on the package and PCB pads. These sensors accurately capture the temperatures the package experiences throughout the thermal reflow cycle. For POP devices, the thermocouple sensors should be mounted in the center of the PCB pads, at the 4 outside corners, and the center of the ball grid array. To mount the thermocouple sensors, drill a hole through the center of the PCB pad. Insert the sensor from the bottom of the board up through the hole and level with the PCB pad surface. Then glue the lead to the board to hold the sensor in place. After a package is mounted, the sensors will be in the center of the PCB pad solder joint, and another sensor should be mounted on the top center of the component body. By using this profile board, a thermal reflow profile can then be created. A proper thermal reflow profile will include 4 steps. The first step is the board preheat. The goal is to bring up the ambient temperature of the board and get the joints in the 125 to 150 degrees Celsius range. This will allow the entire board to heat up and minimize localized warpage to the component site. The second step is the soak stage, also known as flux activation time. With the nozzle down, the temperature at the POP package solder joint should be increased to the 200 to 220 degrees Celsius range. The third step is the peak reflow stage, also known as time above liquidus. The temperature at the POP package solder joint should be increased to the 230 to 250 degrees Celsius range. Step 4 is the cool-down step. The nozzle is raised and the board temperature is brought down to between 130 and 100 degrees Celsius. This allows for handling of the board to perform the PCB pad site dress and cleaning the component site area. This is a graph of a successful thermal reflow profile. The data from the thermal sensors are tightly grouped together throughout the thermal reflow cycle. It also shows the performance of the bottom heater, which controls the board heat, and the top heater, which localizes heat to the target component site being reworked. Once a successful thermal reflow profile is developed, it can be used for POP package removal. Since a POP package is a 2-part package, the 2 components need to be glued together for a successful removal of both components at the same time. Using a plastic syringe, apply a small dot of Loctite 3609 chip bonder adhesive, or its equivalent, to the 4 corners of the package to secure the top component to the bottom component. Be careful not to get any adhesive between the bottom component and PCB surface, as well as surrounding components, otherwise the POP package cannot be removed. With the 2 components glued together, place the board on the rework machine bed. Firmly clamp it down using the board holders. Place the support pins for underside board support to minimize bending and sagging. Cover the open areas with heat shrouds to maximize the heat to the underside of the board. Let the machine run through the thermal reflow cycle to remove the package. During the POP package removal, there will be remnant solder left on the board component site PCB pads. Before installing the new package, the component site PCB pads will need to be site dressed by wicking off the remnant solder from the PCB pads and cleaning the component site area. To dress the site, the following tools are needed: a soldering station, 10 mm solder iron heating tip, core solder wire, wicking tape, flux pen, wire cutters, isopropyl alcohol or IPA, lint-free wiping cloths, and a microscope. To wick the solder, first apply flux to the pads to be cleaned with a soft, lubricated brush. A stiff brush runs the risk of lifting or cratering the pads. Make sure the soldering iron is up to temperature, then apply flux to a clean portion of wicking tape and place it just off the edge of the pads to be wicked, if possible. Tin the iron tip and place the solder tip on the wicking tape. Hold it in place for 2 to 3 seconds to bring the tape up to temperature, then use the iron to draw the wicking tape across the pads. Only go in one direction. After each pass, trim the used wicking tape, reapply flux to a new tape section, and tin the iron tip for each consecutive pass. It's heat that wicks the solder, not pressure, so only a light touch is needed. The speed the iron is passed over the pads is critical. Too quickly and the solder may stick, lifting a pad. Too slowly may overheat the pads and cause delaminating or cratering of pads. Once the entire area has been site dressed to remove the remnant solder, thoroughly wipe and clean it with IPA and clean wipes. Then inspect the component site for any missing, lifted, or damaged PCB pads or passive components. The installation of the pop package is done in 2 steps. The first step is installing the bottom component. Place the board on the Rework machine bed. Firmly clamp it down using the board holders. Place the support pins for underside board support to minimize bending and sagging, and cover the open areas with heat shrouds to maximize the heat to the underside of the board. Apply flux to the target area in perpendicular strokes to ensure complete coverage. Place the new component in the nest on the shuttle tray and start the machine cycle. When prompted, align the component solder spheres to the board component site PCB pads, and let the machine go through the thermal reflow profile to install the bottom component to the site. The second step is installing the top component using Tachyflux. Load the new component on the shuttle tray. Then place the flux reservoir on the glide surface and fill it with Tachyflux. Using a spatula, level the flux. A small remnant of the flux can be left for subsequent installations. Slide the flux reservoir into position. Run the dipping cycle on the machine to apply the Tachyflux to the solder balls on the component. The flux should cover the lower 50% of the solder balls. After the flux is applied, reposition the board and align the new top component to the bottom component and run the thermal reflow cycle to complete the installation of the pop package. By following these steps outlined for creating a thermal reflow profile using a thermal reflow profile board, removal of the pop package, dressing the PCB pad site to remove remnant solder, and placement and reflow of the pop package, a high rate of success can be ensured.